Tutorial 3, Spares Optimization. Introduction. The spares optimization problem is solved by the S2A module of the apmOptimizer. The S2A module finds the optimal quantity of spares in stock in order to reach maximum availability or minimal costs, while complying with user requirements like maximum spare budget, target availability, maximum restoration downtime. In this tutorial, we will show through a simple example how to prepare and perform a spares optimization run. We start with a typical apmOptimizer project. The considered system contains various components that are repaired or discarded and whose spares are stored in two locations. Some items have their stock located at the operational site, and others have their stock located at the repair shop site. The first scenario describes an initial condition where the quantity of spares in stock is not optimal. Initial spares quantities are displayed by clicking on the S2A icon. The dialog that opens shows the current spares quantities, 1 spare per item and a total spares cost of $11,210. In the status bar, the flag spares indicates that the spares quantities are fixed. Before we try to optimize the spares quantities, we want to know how the system performs with the current levels of spares. For that purpose, we perform an LCC computation. When LCC computations are done, the LCC summary dialog appears, showing the main components of cost and the availability of the system. Operational availability is 84%. In the status bar, the LCC flag indicates that computations are valid. In the main grid, different computed parameters like availability, mean downtime or MTBCM are displayed for all items. Now let us optimize the spares quantities. We first open the Common Data dialog in order to set the optimization parameters. In the General tab, we set the accuracy level for the S2A computations. In the Spares tab, we set the optimization target maximum availability, or minimum cost. In our case, we choose maximum availability. Now we will create a new scenario so that we can compare the initial and optimal states. Click on Edit, Scenarios. We call it Scenario 2, Optimal Spares. Since Scenario 2 is a copy of Scenario 1, it has the same fixed spares. In order for the program to modify the initial quantities, we must cancel the initial spares. For that purpose, we click on the S2A icon and Cancel All Spares button. Now we launch the spares optimization. Select the S2A module and then press the Calculate button. When computation is done, the S2A summary dialog appears, showing calculation information and the maximum operational availability reached. Here, 89.18%. The recommended spares quantities at each stock are displayed here, along with the resulting spare cost. For each item, the recommended optimal quantity can be accepted or modified. Recommendations can be fully accepted by clicking on Apply. Note that the spares are now fixed, and S2A flag is up. Now, in order to get the cost aspects of the optimization, we run again the LCC module. Using the trade-off feature, both scenarios can be graphically compared. Click on Results, Trade-off. Choose parameters and scenarios to be displayed. Thank you for your attention.